So the next aspect of magnetic field is magnetic susceptibility. Magnetic what? Like this, be a symbol of what? Magnetic what? Susceptibility. So this susceptibility, you can define it as a dimensional or dimensionless quantity. Let me say what? This is a what? A dimensionless quantity. That is, it has what? No unit and no what? No dimension. So a dimensional quantity that indicates how magnetic material or how much, how what? Much a material will become magnetized. This is the dimensional quantity that indicates how much a material will become magnetized in applied magnetic field. Yes, in an applied magnetic field. We are talking about what? Magnetic susceptibility is a dimensional quantity. It's a quantity without units and without dimension that indicates how much a material can become magnetized in an applied magnetic field. This magnetic susceptibility is the one that will tell us the what? The degree of what? Of magnetism of a material. You know, the magnetized means what? The process of making magnets. So this magnetic susceptibility, it tells us or is measure degree of what? Of magnetism of a material. That is what magnetic what? Susceptibility. Or you can also say what? Or let me take definition. Or I said it's measure degree of what? Of magnetization. Yes. Or it is a measure of degree of magnetization, open bracket, M, of a material in response to a magnetic field. The magnetic field or magnetic strength, we use what? H. So this magnetic susceptibility is just measure the degree of what? Of magnetization or magnetism of a what? Of a material in the presence of what? Applied magnetic field. So mathematically, we can have what? Magnetic susceptibility should be the ratio of what? Magnetization or magnetic dipole movement over what? Over magnetic field strength. This is what is M, this one is what? Is H. So therefore, the magnetic susceptibility will be equal to the what? M over what? Over H. This is the formula for magnetic susceptibility. Let me to call it what? Equation 1. Like I said, that this magnetic susceptibility is measured degree of the what? Of magnetization or magnetism of the what? Of the magnetic material. That is what? Magnetic susceptibility. The magnetic susceptibility can now be classified in material into what? Into three. So types of what? Of material based on magnetic susceptibility. Type of material based on what? Magnetic susceptibility. Types of material based, let me put it there, based on magnetic susceptibility. What are the so this magnetic susceptibility group all material we have into three parts. Let me give you in a tabular form. To group what? All material we have into the what? Into the three, into tabular form. The first one is, let me say, types. Types of material. Yes, we have types of material. The second one, we have magnetic susceptibility. Magnetic susceptibility. The third one, we have behavior of the material to what? To magnets. Behavior of material to magnets. If we have it in this form, see, the first one we have, the first material we have diamagnetic material. For diamagnetic material, the magnetic susceptibility of diamagnetic material always less than what? 0. Magnetic susceptibility of always what? Less than what? 0. And is what? Small or negative. Is a small, now what? Negative. But what happened to the what? To behavior is weakly repelled by magnets. This is what? Weakly repelled by what? By magnets. So magnetic material that weakly repelled by magnets is called diamagnetic material. But the second one, we have paramagnetic material. The magnetic susceptibility of paramagnetic material is always greater than what? 0, but small positive. Small what? Positive. What is the what? Magnetic behavior? Behavior of the material to the magnet. This one is weakly attracted by magnets. So magnetic material that weakly attracts by magnets are called what? Magnetic material. The last one is magnetic material. In ferromagnetic material, the magnetic susceptibility for ferromagnetic material is much greater than what? 1 and very large positive. Very what? Large positive. So, what happened to the behavior of the material to the what? To the magnet. This one is weakly attracted by magnet. This will was strongly attract by magnets. So, if you ask, magnetic material that have magnetic susceptibility greater than 1 is ferro. That's greater than 0 is what? Para. Less than 0 is what? Dia. The magnetic material that weakly attracts magnet is called para. Magnetic material that weakly repel die. Magnetic material that strongly attracts the magnet is called vero. I've explained this magnetic material in my first video on magnetism. Please, if you are familiar with diparamagnet, I explain the difference between them deeply. But our interest here is what? In terms of what? Magnetic susceptibility. So the magnetic susceptibility is the material that we use to classify para, di, and vero. And the next thing is factor that affecting magnetic susceptibility. What are the factors that are affecting magnetic susceptibility? Factor. Factor affecting magnetic susceptibility. Susceptibility. This is a symbol. Susceptibility. This is a symbol. Yes. So the magnetic susceptibility of a material can be affected by 3 major things. The first one is by temperature. What? Temperature. The second one by the nature of material. The third one by strength of magnetic field. Strength of magnetic field. So these are the factor affecting magnetic susceptibility. So I will like to explain the effect of each factor on magnetic susceptibility of each material. The first one, let's start from effect of temperature. Effect of what? Of temperature on magnetic susceptibility. You know that is what, according to based on magnetic susceptibility, material are grouped into 3. They are magnetic, ferro, and para. So I would like to want to look at the effect of temperature on diamagnetics and what happened to the effect of temperature on what effect of temperature on what? On ferromagnetism. If I'm talking of what? Effect of temperature. The first one on what? Magnetic material. Effect of temperature on what? Diamagnetic material. This diamagnetic material, it has nothing to do with what? Temperature. That is, it's independent of temperature change. So this diamagnetic material is what? Independent of temperature change. So the temperature change, it has nothing to do with what? Diamagnetic material. So for that, we can say that what? The diamagnetic material, susceptibility for it should be what? Constant. Constant, but don't forget is what? Small megawatts, negative. So the next one, we have paramagnetic substance. For paramagnetic substance, what is the effects of what? Of temperature on paramagnetic what? Substance. So this paramagnetic substance is inversely. Paramagnetic substance is what? Is inversely proportional to temperature. Is inversely what? Proportional to what? To temperature. Full stop. And this inversely proportional, the relationship between paramagnetic material and temperature can be explained by Curie. Let me say what? This is explained by Curie. By what? By Curie. And the Curie is the one that tells us that what? The paramagnetic substance is inversely proportional to the what? To temperature. That is, the susceptibility is inversely proportional for what? Temperature. And what? The magnetic susceptibility for paramagnetic material is the reciprocal of what? Of absolute temperature. If we change this, we can have it in what? This is equal to the what? C over what? Over T. Where C is Curie constant. T is what? Is temperature. From this expression, we can now say that what? As temperature what? Increases, the magnetic susceptibility of paramagnetic element, the what? Decreases. I say what? As temperature increases, as temperature is what? Increases, the magnetic what? Susceptibility decrease. Hey, when the temperature of diamagnetic material is increases, what happens to the magnetic susceptibility of diamagnetic material? It has nothing to what? To do with it. But whenever the temperature of a material is what? Is increases, and the magnetic susceptibility of the material is decreases, the material is what? Is paramagnetism. called paramagnetic substance. When the what? The temperature of the material is increases and the susceptibility of the what? Of the magnet is what? Is decreases. Tell you that is what? The material is what? Is paramagnetic. But whenever temperature of the material is increases and the susceptibility of the what? Of the material remain unchanged, constant, simply means what? The material is what? Diamagnetic material. And the third one, para what? On ferromagnetic substance. So what is the effect of temperature on a ferromagnetic material? See, this effect of temperature on ferro can be grouped into three. It's based on what? On the Curie temperature. The first of this one is based on what? Based on what? Curie. Is based on Curie temperature. This can be grouped into three based on what? Curie temperature. The first one, below the Curie temperature, the magnetic susceptibility decrease non-linear with temperature. That's the first one. Yeah. So what? Below the what? The Curie temperature, below the Curie what? Temperature, what happened to this magnetic susceptibility? The what? Decrease. Magnetic what? Susceptibility. The what? Magnetic susceptibility decrease. Decrease with no decrease non-linear with temperature. Please note it. But at Curie temperature, at what? Curie what temperature? The ferromagnetism drop and become paramagnetism. At what? At Curie temperature, what happened to what? To magnetism. It will become paramagnetism. At Curie temperature, ferromagnetic material become paramagnetic material. So when the temperature of ferromagnetic material is at Curie temperature, it will become paramagnetic material. And the last one is at above Curie temperature. At above Curie what? Temperature. Yes. What happened to the what? To the ferromagnetism. The susceptibility of ferromagnetism will be equal to what? C over T minus theta. This is what? The magnetic susceptibility of what? Of ferromagnetism. Once again, effect of temperature on a magnetic material vary. For diamagnetism, when the temperature change, the susceptibility of diamagnetism or diamagnetic material is constant. It has nothing to do with what? Temperature change. But for paramagnetism, The effect of temperature is inversely proportional to the magnetic susceptibility of what? Of Vero or para. So when the temperature of paramagnetism is what? Increases, the susceptibility of magnetic of para will be decreases. But when the magnetic susceptibility of ferromagnetism is what? Paramagnetism is what? It increases, the temperature will what? Will decreases. So the paramagnetic material is inversely proportional to temperature change. But in the case of Vero, it's all deal with current temperature. Below the current temperature, what happened? The susceptibility decrease abnormally, which is not linear with what temperature. At current temperature, ferromagnetism become paramagnetism. At above Curie, magnetic susceptibility go to what? Curie constant, absolute temperature, and temperature given. So, and you may ask that what is the Curie temperature himself? And what is what? Curie temperature or Curie point. The Curie temperature is the temperature at which ferromagnetic material lose its own magnetism to become paramagnetic material. Once again, a temperature at which ferromagnetic material lose its own what? Magnetic property and become paramagnetic material. That is what we call what? Curie temperature. So we are done with what? The effect of temperature on magnetic susceptibility. The next one is nature of what? Of material. Let us look at what? Effect of nature of material on magnetic susceptibility. Effects of nature of what? Material. Do you know that is what? The magnetic susceptibility group material into three parts. Abi? Yes, you know, the first one we have is what? Diamagnetic. The what? Magnetic material. Abi? Or diamagnetic elements. What? Elements. So, what is diamagnetic element? Diamagnetic element. Wait, before I will explain diamagnetic element, I'm talking of what? The effect of what? Of nature of what? Of material. Abi? So, what is the nature of material? So, the nature of material simply means what? The atomic. Let me do it. Atomic what? Structure. And electronic what? Electronic configuration. Configuration of elements affects magnetic susceptibility. What? Susceptibility. Based on this susceptibility, we know that what? Magnetic material can be grouped into three. Abi? So I think we have what? Diamagnetic material. Good. The structure and electric configuration of an element affect the magnetic susceptibility. So that's what we have what? Diamagnetic material. The diamagnetic material, what is the material? Any element or magnetic element, any element that completely fill their what? Completely fill the P, D, and F Is it completely fit D? Completely fit D, P or D or F or beta. Any element in periodic table that completely fit what? This orbital, PDF orbital, one of the one, three, or degenerate what? Orbital. Degenerate what? Orbital. Orbital of the same energy level, which is what? PDF. So any element that completely fill what? Degenerate orbitals are called diamagnetic elements. And the elements, they are weakly repel magnets. They are weakly repel magnetic what? Bar. What are the example of these what? Magnetic elements? Take this as an example. If you have what? Neon, Ne. Atomic number of neon is 10. Write out the configuration is 1s2, abi 2s2, and 2p6. These 2p6, draw the what? The shell for 2p6. We have it in this form. We have how many electrons here? 6. By putting the 6 electron inside, what are you going to have? By using unscrew, 1, 2, 3, 4, 5, 6. We can see that is what? This neon is completely p orbital. Any element that is electronic configuration is completely filled with what? P orbital. Is we call it what? They are magnetics. They will weakly repel magnetic substance. Though the second example of this diamagnetic element, we can also have what? Zinc. Look at zinc with atomic number what? 30. The configuration for zinc is what? 1s2, 2s2, 2p6. Abi, we have 3s2, we have 3p6, we have 3d10, and we have 4s2. Check this for what? For zinc. By drawing the what? For d orbital here, we have how many? 1, 2, 3, 4, 5. So d orbital has 10 electrons. Check it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So d orbital here is completely fit. This what make what? The zinc is what? A diamagnetic element. And the zinc is also not a what? A transition element in a periodic table. Any element that is completely fit d orbitals are diamagnetic elements, and they are also what? Non-transition elements. So this is the effect of nature of material. So what? Any material that is completely fit the p or d or f orbitals are diamagnetic. They will repel magnets and magnetic bar. So the next one is, let me check for para. For the paramagnetic what? Element. They are the elements that what? They are completely, they are partially free. If this one is completely free, the paramagnetic elements or substance, they are what? They are partially free the orbital. Let's check example of diamagnetic, paramagnetic. Let me use aluminium. Now give aluminium as an example of it now. Yes, aluminium. Let's check aluminium. Parallel field what? DP orbitals, not D alone, maybe P, maybe D, maybe F. So, example, let me use aluminium, which is atomic number 13. It has one S2, two S2, two P6, and it's also about two P6, abi? We have three S2 and three P added together 1. So if you look at what this P we have here, the P here is partially filled. Abi, it's partially what filled. We have how many here? 1. So that is major reason why the aluminium is para what? Magnetic. Let me give you one more example. We have manganese. Manganese with atomic number what? What is the manganate? Atomic number 25. Yes, remember 25. The configuration will be 1s2, 2s2, 2p6, 3s2, 3p6. Yes, 3p what? 6. 4. Let me see. 4s2, 3d5. So this 3d5, check it. 1, 2, 3, 4. Put the electron inside. We are going to have what? 1, 2, 3, 4, 5. They are partially filled. So that is how what the nature of material affects this. So we can group the materials into 3 based on the what any element that is completely filled, either p or d orbitals are diamagnets. They will repel magnets. That partially filled, abi either p orbital or d orbital, they will they will weakly attract, where vero also partially filled but strongly attract magnetic field. So that is all about what magnetic susceptibility. Let's Yes, let me add this to it. Application of magnetic susceptibility. Uses, you may ask, of magnetic what? Susceptibility. What is the application? What are the uses? Number one, you can use it for classification of material to diamagnetic, para, and ferromagnetics. We can use what? Magnetic susceptibility to classify material into 3: para, di, and ferro. We can use it in magnetic resonance imaging. Magnetic what? Resonance imaging. We can use it in what? Magnetic resonance. Resonance imaging. We can also use in construction of magnetic shading material. The shading material that can prevent the entry of magnetic field into our body. We can use what? Magnetic susceptibility to construct such materials. The next thing is what? Is permeability of magnets.